Well, good morning, YouTube. This is RVermel47 coming to you from Dallas, Texas. Making this video on June the 9th, 2011, and it is 10:25 a.m. Central Time for me here. I know yesterday I talked about waiting on the interplanetary shockwave from the coronal mass ejection headed towards Earth, and it looks like it made it, although it's not impressive at all. About a couple hours after midnight last night Central Time, looking at the solar wind parameters here, I see that the wind speed dropped, and this would be about that'd be 1 a.m. Central Time here, and then jumped up about 150 kilometers per second. At the same time, the BZ component, the north-south component of the solar wind, also went positive or north. Then did drop down a little there for a while into the southern range, where, as I talk about, anytime the BZ component is in a negative or southern orientation, it kind of means our shields are weak or down, our magnetic shield. And then it quickly went back up above, which is good because then our shields are up, which that keeps us from having a violent reaction to the incoming shock wave. Again, the speed has fallen off, as you can see. One thing that catches my eye is this is particle density, and it increased by like tenfold right after, not too long after the shock hit, and it stayed up there for a while. The temperature of the particles dropped, so we're still in the process of going through this wave. It looks like, though, our magnetosphere that protects us from things like this went into the right mode and went north and kind of helped buffer that a bit, so it keeps us from having too big of a geomagnetic storm. So again, we were thinking this was going to be a glancing blow, but I know the media hyped this up, and of course, what's new, they like to hype anything up. Anyway, let me let you look at another chart here. Now, this is the GOES magnetometer. In other words, it's the magnetometer, the instrument aboard the GOES 13 satellite, and it's what we look at to see how well our magnetosphere is behaving at the moment. And again, we do see some agitation that happened about the time of our shock last night, and it looks like the beginnings of at least a minor geomagnetic storm. Again, nothing real big yet on here. Here's our normal days, and then we get the hit. So it's kind of like think of it whenever the interplanetary shockwave hit, it rings our magnetosphere like a big gong. It's like a big gong being hit, and so this starts shaking and moving all over and stuff. But right now it has gone up, and we'll probably see it start shaking down again. Nothing major at all. Even the K index did respond. We made it up to a K index of 3. Now, just what I showed you with the GOES magnetometer, I would say this will stay at least probably at 3, if not probably come up a little more, as again the geomagnetosphere or the magnetosphere remains are agitated, not necessarily unstable, but agitated by the current shock that's hitting us. And it does continue to flow. I mean, as I showed you on the solar wind parameters earlier. So a geomagnetic storm is still definitely probably going to happen, but it still doesn't look like it's going to be near severe as, again, it was hyped up to be. And that's a good thing, again, for our power grids and anything that's affected by a strong geomagnetic storm. Quick look here at the proton flux, and again, protons remain elevated, well below storm levels. Storm levels, remember, were anytime that the greater than 10 mega electron volt is above this line here, we are considered in S1 storm mode. But again, it dropped, and it's continued to drop. Now it's kind of evened out elevated, because normally we see them pretty much down here. So, and it'll stay kind of elevated, and right there it kind of looks like that's also this little jump or drop here and then jump probably happened right around the same time as the interplanetary shockwave hit, because it would have had some protons with it, since that was a proton flare that caused the shockwave or the coronal mass ejection. And then here's a look at the Gakona, Alaska HARP facility induction magnetometer. Again, looks like we picked up some of the interference from the geomagnetic or the interplanetary shockwave from the geomagnetic field, which agitates the ionosphere. This is where the shock would have come in, right around here, so there was a delay before this chart anyway shows some reaction time to it. Otherwise, HARP continues to be kind of eerily just stable and quiet from what we've seen since I started looking at it anyway. And just for reference, the interplanetary shockwave, when it did hit, which is called a geomagnetic sudden impulse also, it was a measly 15 nanoteslas, which is not very hard. So again, it's probably was a slower and thicker mass that hit. And again, so far a major geomagnetic storm has failed to materialize. Again, some substorming, even some minor storming could be expected over the next 12, probably to 24 hours at the most. Anyway, that's it for your space Earth weather connection look. I'm doing a separate one on weather, which I'll do next, just because I didn't want to make this such a long video like I did last time, and I still probably made it too long. Anyway, y'all have a good one.